Welcome to video 5.1 on balancing chemical reactions. This video is going to teach you how to understand how chemical reactions are expressed and written using the symbols, subscripts, and even different letters and arrows to demonstrate a chemical reaction. In this video, you're also going to learn how to balance and write out your own chemical reactions. There's a few vocab terms we'll be looking at. Anytime, again, you don't understand or pick it up in the context or don't like the way I define it, pause the video, check out Google, and you'll be able to pick it up. But they all should be pretty straightforward from this point on. So this video is really dealing with chemical reactions. And so let's remind ourselves, what is a chemical reaction? A chemical reaction is this idea of how we change the chemical composition of something. I started with one chemical or one element originally, and then something happened to it that formed a new product that changed the chemical from what it was to something new. Previously, we dealt a lot with physical changes and physical reactions where water turned from a liquid to solid, but it was still water. But now we are changing the composition of the chemicals or of elements. So in a chemical reaction, we are transforming the reactants of a chemical equation into the products. And we use chemical equations as a way to express what is going on. So these chemical equations use symbols and formulas, much like what we've been doing already when we wrote our compounds out. And it's going to help us to identify what the reactants are and what our products will be. So how do we know a chemical reaction has occurred? What do we look for? And again, this is slight review, but what do we look for? What do we try to recognize? How do we know if an element or a chemical was changed? Well, there's going to be some kind of energy changed. It could either be releasing heat, or it could be releasing light, or sometimes it could be even absorbing heat or absorbing light. You'll notice a color change when a chemical reaction occurs. You'll see a gas evolve or a gas come off. That will also indicate that there's a chemical change occurring. And then also one of the big ones in dealing with solutions is you will form a precipitate. Remember, a precipitate is when you just form a solid inside a solution. So to the right here on this video, it shows you a picture of a precipitate. We have a liquid coming out of the dropper. We have a liquid meeting inside the test tube. And when they come together, they form a precipitate, which is just simply a solid inside the solution. So our chemical reactions all must obey the law of conservation of mass, meaning that matter can never be created nor destroyed. Meaning the number of atoms you have on the left of your chemical equation has to equal the number of atoms on the right. So here I have N2. That tells me there's 2 nitrogen atoms here. Over here, when we use what's called a coefficient, that's the big number in front of a compound, that 2 says I have 2 NH3s. It doubles this whole compound here. So that 2 tells me now I have 2 nitrogen atoms on the right. So 2 nitrogen atoms here, 2 nitrogen atoms here. 6 hydrogen atoms in the reactant side, 6 hydrogen atoms on the product side. So in order to write our chemical reactions, we have to use coefficients to balance out the equation. And that's what this video is dealing with. You've already learned how to write out your elements and your chemicals. That was all last unit. But now we're going to put them into reactions and we're going to balance them out. So it's key to remember from Unit 4 how to write the chemical formulas correctly based upon their oxidation numbers. And then again, you can write out chemical reactions with using formulas like this, or we even see it sometimes written in words. So here is the steps to balancing a chemical equation. First of all, you want to make sure that you wrote out all your reactants and products correctly. Make sure all the chemical formulas are correct. If I tell you it's copper, make sure you understand how to write Cu. If I tell you it's silver nitrate, you know how to write silver nitrate. If I tell you it's copper nitrates being produced, tell me you know how to go through and write that out using your oxidation numbers from Unit 4. And then again, if I say silver is produced, you got to be able to find the silver element on your periodic table and write down Ag correctly. So step 1 is just write down all the information the problem gives you, meaning write down and make sure all the chemicals and elements are written correctly. And again, make sure the compounds are written correctly based upon the oxidation numbers. And then number 2, this is actually what we're learning new here. Number 2 is balance the equation to make the number of atoms to the left of the arrow, to the reactant side, balance the number of atoms or have the same number of atoms to the right or on the product side based upon, again, the subscripts and the coefficients. So we're going to change the coefficients to make sure the atoms to the left equal the atoms to the right. I call this playing ping pong, and I'll show you what I mean by this in a second with the practice problem. So again, how do I balance a chemical equation? Well, first of all, write out all the formulas correctly and all the elements correctly. So basically set up the chemical equation. And then 2, add in coefficients to balance out the number of atoms to make sure you have the same number of atoms of each element on each side. Again, pretty straightforward. Once you see a few of these, you'll jump right along and you'll enjoy this. Some symbols to learn along the way to, again, express what's happening in the chemical reaction is we have an S, which stands for solid. Like copper here is a solid. It's a metal. L stands for liquid. G stands for a gas. AQ stands for aqueous. So right here, silver nitrate is dissolved in water, so it's aqueous. So the water doesn't really react here, so we don't have it in the chemical reaction. But know that this is present in water by seeing the AQ, and this is present in water because of the AQ here. And then the arrow here is the yield sign. It shows that a reaction is occurring. And again, it splits up your reactants on the left and your products on the right. So let me go ahead and just show you again with my own hand how to do one practice problem. What I mean by saying play ping pong, and then I'll let you try the second one on your own. So on this first one here, I got some tips I'll give you below, but really it doesn't matter which element you start with, it's whatever you want to do. Our suggestion is just start with whichever element looks the scariest. There's not any of these that look scary, so we're just going to start the carbon. And my whole goal here is to have the same number of carbon atoms on the left that I have on the right. And so again, I have 1 carbon here, and I have 1 carbon here. So far, the carbon is balanced. So when I say play ping pong, you pick an element, you jump to the other side of the net of the yield sign, and then you make sure that number is balanced. And then you look at the other element with it. There's 2 oxygens, so now I play ping pong, jump over here. There's a 2 here, so my oxygens are balanced. And so now I have my last element, hydrogen. I jump over here. I see there's 2 hydrogens here. So now I need to double that. So now I have 4 hydrogens. So I keep playing ping pong. Now that I have 4 hydrogens, how many oxygens do I have here? I have 2 plus 2. So now I got to come back over to this side and add a 2 here to double my amount of oxygens to get my 4 oxygens. So again, play ping pong. Pick an element and just jump around. 1 and 1, 2 and 2, 4. Oh, I got to double that. Oh, now I got to play some more ping pong. I got 2 oxygens plus 2 oxygens. I have to have a 2 here to get my 4. Pause the video and then try this one by yourself. We already did the first step for you in terms of making sure the elements and chemicals are written correctly, but practice balancing this. Again, start with whichever element looks the scariest with you and then bounce back and forth. I'll wait. Okay, make sure you pause the video, try this yourself. Okay, welcome back. All right, again, pick any element you want to start with. None of this really scares me, so I'm just going to start with zinc. Zinc, zinc, there's 1 and 1. I see there's 2 chlorines here, so now I got to jump back. I only have 1 chlorine, so I have to add a coefficient. We do not add a 2 here, because if I add a 2 here, I am changing the chemical. We don't do that. The chemical is already written correctly, based upon what we learned in Unit 4. So I only add coefficients. So now I got 2 hydrogens. I jump over here. I see I got 2 hydrogens. So we are done. That was very simple. Now, if you want, you can go and put 1s through here. You don't really need to. I kind of like leaving them blank, but it's up to you. So a few other tips I got for you as you do these. Again, pick any element that looks the most difficult to balance. In this case, your chlorine would probably be the most difficult because he's the only one with the subscript. So first tip, start somewhere, pick any element, the one that looks most difficult, balance that one out first. The second tip I got for you guys, and I have these written down in the next 2 slides, is leave the single elements for last. So when you come across something like H2, when he's by himself, leave that for last, because him and zinc, since they're individual elements, I could put any number I need here to get this to balance out. So save those guys for last. That's a good tip. Also, if you get stuck, try starting over again from scratch with another element, or try just doubling your coefficients, and you'll see what I mean as you practice this more. All right. So now we're going to have one more practice to do. I really want you again to pause the video, take the time to try this yourself. This is going to be doing the whole thing from scratch. This is going to need to use your Unit 4 knowledge of how to write out chemical equations and write out chemical compounds, I should say, and then be able to read the equation and turn it into a reaction, and then go through and balance it. So pause the video and check it out, or try it yourself. All right, welcome back. All right, so as we go through here, I just need to read the word version of the equation and turn it into a chemical reaction based upon the symbols. So the first thing I see here is I got aluminum sulfide. So just like we learned in last chapter, I have to be able to write out the correct chemical formula for aluminum sulfide to do this. So how do I write out the compound aluminum sulfide? Write down the individual elements. Go ahead and write their charges in the top right corner. So again, aluminum's a +3. Sulfur, since he's listed second, he's the anion, he gets to pick his charge of -2. And then we just simply do the cross, put the 2 and the 3 down here respectively. So aluminum sulfide is Al2S3. So again, these coefficients came because of the correct name and the correct chemical formula. Then as I read, it reacts, that's a plus, with calcium hydroxide. So again, what was calcium hydroxide? Okay, well, again, periodic table, calcium is a +2. Hydroxide over here is a -1. It's on the side here. Again, you guys should all be review. Again, that 2 goes here, that 1 goes here, and then I rewrite it nice and clean as CaOH2. Now it says to form aluminum hydroxide. So that word to form tells me I need an arrow here. Again, aluminum hydroxide, AlOH. I'm going to speed it up now a little bit. Okay, so I have to clearly be able to write the correct chemical compounds down. And then I have calcium sulfide. And so that would simply be CaCS. So there's your first step. Can you go through and can you write down all the correct chemicals? Now we have to go through and balance it. So now here's where we're just going to play ping pong. Pick any element that looks the scariest. For me, I think the hydroxide's the scariest. You can start there, but if you're not good at math, let's just start with the aluminum first and see where we go. One other tip here is notice how these are polyatomic ions. Keep those guys together. It'll make your life a lot easier. Remember, we treat these as an individual compound within a compound. So let's start with aluminum. Aluminum, there's 2. So I need to play a 2 here. Now that gives me 6 hydroxides. So if I need 6 hydroxides on this side, and I already have 2, I need to put a 3 here. So I'm going to triple the set of 2. I'm going to double the set of 3 here. So now I have 3 calcium. So I come over here and write a 3. Now I have 3 sulfurs, and I have 3 sulfurs. So again, all I did was just play ping pong, go back and forth, put in these right coefficients to get this to balance out. Again, this just is a skill. It's a process. You just got to learn, take some time practicing it. But once you kind of get it down, it's one of those things where you're going to find it's pretty easy. So here are the tips. Good rules to follow. Again, start with whichever element looks the hardest to balance. Work back and forth between the reactants and products. Again, we're playing ping pong here. Do one element at a time, left and right. If you need to, make a chart. There's no shame in that. Here's what a chart would look like if you wanted to make a chart. So if I wanted to go through here, all I'm simply trying to do is say how many atoms, sulfurs, calciums, hydroxides, aluminums, OHs, and calciums and sulfur. So just go through and make a chart. So what you're going to do is say, okay, I got 2 aluminums here. How many aluminums do I need here? Well, I need 2. Okay, double check. Yep, bam, got it. How many hydroxides do I have? Well, I have 2 and I have 3. So once I double them up, now I have 6. Now I have 6. So you can make a chart like that. Double check it. You got 3 and 3 sulfurs, 3 calciums, 3 sulfurs. So if you want to go through and make a chart to double check your work or to help you along the way, that's fine. But really, if you just play ping pong, I think you'll find it's pretty straightforward. Keep your polyatomic ions together. Again, do individual single elements last. And if you get stuck, if you start somewhere and the numbers just don't work out, try it starting again with a new element, or even just try doubling your coefficients. So really, this video was about how to write chemical equations. Chemical equations are a representation of chemical reactions and how we write things out using words and chemical symbols. Chemical equations have to be balanced to obey the law of conservation of matter. Law of conservation of mass. And then that's how we write a balanced chemical equation using the correctly written chemical formulas. Have a great day.